All right, so we're going to look at some pseudocode stuff here. Basically, it's the pseudocode required to use trapeziums to estimate the area under a curve. So let's talk through the code first, and then we'll do the first pass of the code so you can sort of see how it works, and then a bit of a visual here to help. So the first part says define f of x. So I've got some function that's x cubed plus 2x squared plus 3. So this is just the first part of our code. It just means it's just how you tell the code what the function is that you're dealing with. Okay, the first thing says that start with a being 0, start with b being 5, and start with n being 10. So let's just talk about what these are. So basically our question that we're trying to answer is what is an estimate of the area between 0 and 5 of this function f of x? And it wants us to use 10 trapeziums to estimate that area. So that's sort of what's going on in this first part. All right, assign h to be b minus a on n. Okay, h in this instance is going to represent the width of our trapezium. So it's sort of the base width of our trapeziums. And I think I'll just explain this more. For the first value of h, well, let's just work it out. B minus a, so it's 5 minus 0 divided by n, which is 10. So it's 5 minus 0 is 5, divided by 10 is 0.5. So it's basically saying use 10 rectangles of width 0.5 to estimate the area under the curve between 0 and 5. Okay, and then it says assign left to be a. So the left part of your first trapezium will be 0. And the right part of your first trapezium will be 0 plus 0.5, which was h. Okay, but that obviously changes at each pass of the code. So you'll see what we mean in a moment. All right, start the sum being at 0. So that's going to sum all the areas of these trapeziums. All right, and then we're going to use what's called a for loop. So for I from 1 to n. So basically, do this for n times, essentially, and n is 10. So do it for all 10 trapeziums. Okay, this strip basically represents the area of the trapezium. Now, if you think about the area of the trapezium, it's going to be 0.5 times the function evaluated at the left side of the trapezium plus the function evaluated at the right side of the trapezium multiplied by the width of the trapezium. And if you're unsure what that is essentially just the trapezium formula. Remember, a trapezium is sort of like an average rectangle. If you've got a trapezium and it's got two different side heights, say A and B, it'll take the average, you take the average height of those, and that's why you multiply by 0.5 to find sort of the average height of your trapezium and then multiply by the width of it. Okay, and then the sum, your new sum becomes the sum, which was 0 plus the strip area, which was whatever's calculated here. All right, and then your new left point becomes your previous left point plus h, which is, so you sort of moves along to the next trapezium, right, and then add, to get your next right point, add 0.5. Okay, and then you end your for loop, and then you print the sum. All right, it'll help if I show you an example first. So this first part here, as we said, is 5 minus 0 on 10. So it's saying that h is 0.5. Okay, the left point is going to start at 0. That's the first left point of our first trapezium. The right point is going to be 0 plus 0.5, which is 0.5. Okay, the first strip, so the way we're going to calculate our first trapezium is using this, and this will help if you see this first trapezium here. All right, so it's 0.5 times f of 0 plus f of 0.5 times 0.5. You know, that's just the area of this shape here. Okay, and then the sum of the first one, so when our first pass of our code turns out to be, this area of this is 53 on 32. Okay, and then you add that to the previous sum. So yeah, that's our new sum, and then so we're going to run that back into the code, and then we're going to keep adding on to that. Okay, our new left point is now going to be 0.5, and our new right point is now going to be 1. And so we get the next trapezium, and then you run the code again, you get the area of this trapezium, add it to the sum, add the next one, add the next one, keep going, add all these up. And once the code has run all that, you'll print the sum, and the sum of that will be the sum of all these trapeziums. So pseudocode can be a little bit tricky to wrap your head around in terms of the notation. The maths is not particularly difficult. You just need to know what the area of your trapezium is. It's just sort of wrapping your head around how you can represent that process as an iterative process or as a code. Okay, so hopefully that clarifies how those pseudocode area under curves works.